My name is Asege. I'm Grace and I'm representing Group 1. I am here to derive the expected mean of the negative binomial distribution. From the probability density function, it is given by P into R. P is equal to X plus R minus 1, combination of R minus 1, probability of the success times probability of the failure. But for this case, when we are getting the negative binomial, this interchanges. This turns out to be the probability for the failure, and this is the probability for the success. So we write it as the expected value of the negative binomial is equal to the summation of x from 0 to infinity into x, open brackets, x plus r minus 1, combination of r minus 1, times the failure times the success. Now in this case, when we substitute in the x for 0, this tends to 0, and for this case we take for the value of x is equal to 1, which will be x. When we put x is equals to 1, we shall have this. We shall have that. So in that case, we expand this combination. So when we expand this combination, we shall end up with something like this. X plus r minus 1 factorial out of r minus 1 factorial into brackets x plus r minus 1 minus r minus 1 factorial, but we put this into brackets, times the probability of the failure times the probability of the success. So this automatically cancels out and we end up with something of this sort. This is x plus r minus 1 factorial out of r minus 1 factorial x factorial this. So, and then we want to cancel out this x, so we expand this factorial. I've expanded this factorial x. So this automatically will cancel out, and then this will be my equation 1. That will be my equation 1. So these statements from this equation, one of them is I'm going to get r out of r factorial, and this I'm going to get it from 1 minus r minus 1 from this. So this will end up, this statement is true. You can see that it is true from this. It is true, and then this other statement is still true from this. I got it through that when these they have the same base and it's in multiplication, so when I add them I end up with. So these statements are true. We have derived them from these, as you can see. So we end up substituting all this and this into equation 1. So when we substitute them into equation 1, we shall have this. We shall have that. Shall have that. So we factor out the constants, and the constants here are everywhere that there is no x. So when we cancel, when we factor out the factors, we shall have this. We shall have that. and this will be our equation 2. So here we let w to be x minus 1, and if x is equals to 1, of course w is equals to 0, and x will be equal to w plus 1. So we'll still let s to be r plus 1, so our r will be equal to s minus 1. So we still substitute this r and w into our equation 2. So when we substitute those two into our equation 2, we shall end up with something of this sort: summation of x, that plus 1 plus s minus 1 minus 1 factorial out of s minus 1 factorial w factorial. We shall end up with something of this sort. So here, this will simplify this. Simplify this. And this will be our equation 3. But we all know that the probability density function is equals to 1. So this whole thing is equal to 1. So we just, when we substitute that in, our expected value will be equal to this, the constant that we had factored out, times the 1 plus times this whole probability, which is equals to 1. So we shall end up with this, because this literally means the inverse. We shall have rp out of 1 minus p. That.
My name is Ashima. I'm representing Group 1. I'll be deriving the standard deviation using the variance for negative binomial. Now, for standard deviation, we have to find the square root of the variance, and therefore we have to find the variance of x. Now, this is the equation to find the variance of x, that is e is into x squared minus the expected value squared. So, as my colleague did in the first video, we're going to have variance of x, e into x squared minus, we are going to replace what she found, since she found the expected value in the first number, of 1 minus 3 squared. So, we have to first figure this out. Therefore, we are going to first work out to find the expected value of x squared, and therefore it's equivalent, it's equal to the summation, where x is equal to 0 and it tends to infinity, x squared times the probability of x plus r minus 1, r minus 1. So we are going to first find substitute for 0, where we shall have this plus the summation, where x is equal to 1 of the same formula. This. And when we substitute for 0, this all becomes 0, and therefore we take where x is equal to 1. So for x equals to 1, we shall have the summation where x is equal to 1, x squared, where it tends to be 0. And then we have the combination of x plus r minus 1, r minus 1, and the probability that's where we have the failure to power x, and then the success, which is 1 minus p to power r. So therefore, we expand it to infinity, x squared. We are going to have, this is into x plus r minus 1 factorial, r minus 1 factorial, into x plus r minus 1 minus r minus 1, the whole bracket is factorial, and therefore the failure and then the success. So for this case, we shall simplify, and when we do that, where x is equal to 1 and it tends to infinity, we shall have x by x, which is an expanded form of x squared, and we shall keep the numerator. But when you simplify everything here, we shall have x factorial into r minus 1 factorial. And for cases, when you expand x factorial, we shall have x into x minus 1 factorial, r minus 1 factorial, x plus r minus 1. So here the success is still here and the failure too. Summation x equals to 1 infinity x times x. We shall cancel. For x, leaving us with 1x. So when you continue, we have x, which is x plus r minus 1. All this is factorial into x minus 1 factorial, r minus 1 factorial. Failure to the power x and the success to the power r. So from the above equation, as we saw in part A, we're going to simplify 1 out of r minus 1 factorial, which will give us 1 over r minus 1 factorial will be equivalent to r over r factorial. And to simplify the failure to the power x, be the same, it will be equivalent to p to the power 1, probability to the power x minus 1. Same working will be done for the success to the power r, which will be equivalent to 1 minus p to the power r plus 1 times 1 minus p to the power negative 1. So if you substitute this equation, we shall have a general equation of x equals to 1 that tends to infinity, x into r into x plus r minus 1 factorial, r over r factorial into x minus 1 factorial, p x minus 1 into 1 minus p to the power r plus 1, 1 minus p to the power negative 1. We shall pause.
Okay.
Therefore, we shall take out the constants, which in this case is rp into 1 minus p to the power negative 1. The summation will be x minus 1, which tends to infinity. We shall have x into the same variables we had in the step above, r factorial into x minus 1 factorial p to the power x minus 1, sorry, 1 minus p r plus 1. This will be our equation. So we are going to let's that b equals to x minus 1, and therefore we shall have x being equal to w plus 1, and then s being equals to r plus 1, where we have r being equal to x minus 1. So substituting the above into the second equation here, we shall have rp into 1 minus p to the power negative 1, and then x 1 x tends to infinity. We shall actually, this will become, for x we have w plus 1 into w plus 1. We are just going to substitute this into the second equation. Plus 1 plus r minus 1 third, which, so after substituting this into equation 2, we shall have rp into 1 minus p negative 1, and then you're going to put this into a bigger bracket. We have the summation w equals to 0, infinity, and then w into w plus s minus 1 factorial over s minus 1 w factorial. Of course, with the successes and the failures, plus 1, because in this case we are expanding this, and then we shall have 1 into the same which is the same equation over here. That's s minus 1 factorial out of s minus 1 factorial w factorial, keeping failures and successes. So this that is in the bigger bracket will be considered our equation 3. And therefore, if you remember for negative binomial, this is the PDF, which is always equated to 1, as we shall see.
It's first and max, please.
So we have the successes and the failures here, which all equate to 1. And then for the case of this, where we work with this part of the equation 3, s1 factorial, s minus 1 factorial, w factorial, the successes and failures. So it is equal to the expectation of w, which is sp over 1 minus p. So if we substitute this into equation 3, we shall have our constants, which are this into sp over 1 minus p plus the 1 plus 1, which is also equal to rp. If we simplify this, which is rp over a negative power is a denominator, 1p, into sp over 1 minus p plus 1. So we know that s is equal to r plus 1. So for wherever we shall find s, we shall substitute it with r plus 1. So we have this, we had already simplified, which is 1 minus p. It will be into r plus 1 p minus 1 minus p plus 1. This will become, if we expand the brackets, we shall have rp over 1 minus p into rp plus p plus 1 minus p over 1 minus p. In this case, we are taking the LCM. Therefore, if we continue, we shall have rp over 1 minus p be equal to rp plus 1 over p. Therefore, this all equates to rp over 1 minus p squared, for this case, into rp plus 1. Therefore, the expectation of x squared, expected value of x squared is equal to rp over 1 minus p squared into rp plus 1. So back to this equation 1, where we had substituted for the expected value squared, we shall come back, work out the variance, which you remember is this, minus rp over 1 minus p squared. So we are going to substitute for for the values we have found. We are going to have rp over 1 minus p squared into rp plus 1 v minus this all squared. So we shall have rp over 1 minus p squared plus the rp over 1 minus p squared minus rp over 1 minus p squared. So when we look at this, we know that this and this will cancel, leaving us with RP over 1 minus P squared. And therefore, this is the variance. And we all know that standard deviation, which I'll abbreviate by SD, is got from finding the square root of the variance.